Okay. Yeah, so I'm gonna spend a little more time here, if I can have time. So now I'm wearing my OPC Foundation hat, okay? So no more Microsoft products, anything like that. So I'm, like you saw in the previous slide, I'm involved in various different working groups. I'm in the technical control board and the marketing control board of the OPC Foundation. And I'm also the chair of this new thing called the Cloud Initiative. So what's that all about? And now I'm losing focus again. Let me see if I can get that working. Okay. So, turns out, we were creating all these working groups for cloud-related use of OPC UA, and there wasn't really a good kind of steering board or kind of coordination going on between the working groups, like in the field level communication work that we did. So I pushed hard to create the Cloud Initiative, or Cloud Exchange, because we have FX, Field Exchange, now we have Cloud Exchange, to coordinate all of that. And I said, well, we need to have all the cloud vendors at the table, and ideally we also have a set of end users telling us how they want to use OPC UA in the cloud. And of course, the industrial automation providers that are part of the OPC Foundation and on the board of the OPC Foundation, they're also part of this. So this is what we ended up with. So we have every major cloud vendor present, which I think is fantastic. We have quite a few household names here that are end users telling us, do this, don't do that. And of course, we have the support from the who's who of the automation industry also supporting us. So that's already a good start. And what do we build it for? Well, it's all about interoperability of cloud applications using OPC UA technology. Because let's face it, we don't want to repeat the field bus wars in the cloud. We really don't have the time to spend the next 20 years trying to consolidate different approaches when it comes to cloud applications in the manufacturing space, unless you disagree. So with that, we said, okay, let's define a few goals. First and foremost, interoperability, but also how to use companion specs in cloud applications, and obviously the cloud library has a big impact there. But we also wanted to build a cloud reference architecture. Now I thought, should I show it? But we're still discussing it. We haven't got agreement yet, so I'm not going to show it. But you know, it's going to be very complete when it comes to use of OPC UA technology. All the different pieces from all the different working groups will be in the reference architecture. And we decided, similar to what we did for FX, we decided to create a protected identity, UA-CX for Cloud Exchange. So people, like end users, manufacturers, can order eventually a product that is CX compatible. And for that, of course, we need validation and a certification program. So we're going to set that up as well. Now, the Cloud Initiative was announced at HMI this year, and we had a big booth last week at SPS. So we are on a good path, but we're at the beginning of that path, right? So it's brand new, but we're already making good progress. So what does that look like in terms of how it fits into the OPC Foundation? So on the top, you have the board of directors, and the Cloud Initiative has a steering committee, and this steering committee basically aligns with the technical control board and the marketing control board. It has its own cloud marketing group, and then the cloud working groups, you know, are managed by the steering committee. So they basically get to say and sign off on the work that happens in the working groups. And then the end user council is basically set up specifically for two-way alignment and advice. Advises sounds wrong from a grammar perspective. I need to tell Stefan about this. But anyway, you know what I mean. So the end user council gives advice to the Cloud Initiative Steering Committee, and the Cloud Initiative Steering Committee reports to the end user council about what we're doing and when we're doing it. So we already have quite a few working groups that exist today that we moved into the cloud initiative. So it started with the OPC UA over MQTT working group, which exists for some time now. And again, I already talked about the REST interface. That's part of it, the cloud library, of course. We set up a new AI working group. Of course, you need to have an AI working group these days, right? So that's there. The metaverse working group is pretty much complete, but it was also moved. And then we have a few new ones here that you probably haven't heard of. So I'll talk a little bit about these 5 new ones that are now part of the cloud initiative. And cloud marketing is just doing marketing for the cloud initiative. All right, it's pretty straightforward. So what are those 5 about? So let's talk about asset onboarding once again. And here is an interesting chart. So you might think, well, everything is discoverable and you have your PLCs, you just read out the tags from the PLCs. Well, it turns out that only really applies to 10% of all assets out there. Now, don't get wrapped around the axle regarding these numbers, the estimated numbers, but they're gonna be roughly right. It's not gonna be 50%, 50% or anything like that, right? So let's say this is correct and only 10% are discoverable. Well, then about 4% overall are OPC UA enabled these days. And obviously, if you have an OPC UA enabled PLC, you don't need industrial connectivity software to onboard it to OPC UA. It already is OPC UA. However, then there is the non-OPC UA enabled PLCs, and that's where the automatic asset mapping by the connectivity software comes in. You connect to it, it reads out all the tags from the PLC, maps them automatically OPC UA, presents an OPC UA server to you, you connect to that. OPC UA has discoverability, so you can just discover the OPC UA server in the industrial connectivity software, and everything's happy and dandy, and you're on your way. What happens here? Well, nothing happens here, because you can't discover anything. You will need to provide the metadata yourself. So we said, why not use Web of Things for that use case, the 90% case? So it should be high priority. Web of Things is a W3C standard. It's supported by Bosch, Siemens, Microsoft. Who else? Oracle. A few more. I can't remember, but those are the ones I remember. So it's well accepted in the industry. And then, of course, you have 2 different types of non-discoverable assets. You have the fixed function, fixed data model assets, like your energy meter, your valves, your pumps, all that stuff. It means the data model never changes. It's not programmable. For that, you can do an automatic mapping based on the thing description that you probably should get from the vendor of the asset. And if the asset vendor says, I can't generate a Web of Things file for you, they're lying. Just tell them, you're creating a PDF for the asset, right? Yeah. And that PDF has all the tags in it. Yeah. And those tags, you didn't write them yourself. You grabbed them from your product database. Well, yeah. Well, then you can also create a Web of Things file. It should be just the same as creating a PDF. A Web of Things file is a JSON document. The big difference between a PDF and a JSON document is the JSON document is machine readable. The PDF isn't. So you should be able to get those things from the asset vendor. And if they refuse, don't buy the asset. If you've already bought the asset, use Copilot to try to generate the Web of Things file automatically. Like I mentioned, it's better than typing it in from scratch, trust me. Even if it's only 90% correct, it's a good starting point. And then for the programmable assets, and those are the ones where the data model is going to be different every time, well, there you can actually export the engineering project that at least a machine builder should have, to some file format that will then, like it's usually CSV file or automation ML is used quite a bit. And then using that file, you can convert it automatically into a Web of Things file. And I contributed some tools that are also in the Edge translator repo on the OPC Foundation GitHub webpage to do that conversion. It's called What File Generator. You won't miss it. And it does CSV file, because Rockwell uses a CSV file from their engineering tool as an export. Siemens uses automation ML. And there's a bunch of others. So I tried to get them all, but it's an open source project. If you find that there's a file format that you have access to for your engineering project, for your PLC, that's not there, contribute it. We need your help. Because only if everybody pulls and rows in one direction can we actually make progress here. So that's basically the idea, to get everything to OPC UA with the help of WAT files if needed. And WAT files, or WAT has protocol bindings for things like Modbus and BACnet. There's a protocol binding in the works for MQTT-enabled assets. Yes, we could do better on the protocol binding side of things. There's a working group specifically for OPC UA. You might think, why OPC UA? I thought, once you have an OPC UA server, you're done. Well, yes and no. Some people want to not just map to OPC UA, but into an OPC UA companion spec, for example, a robotics companion spec, or a Weinstefan companion spec if you're in the food and beverage industry. So mapping from OPC UA to OPC UA plus companion spec is actually a valid use case. So we're supporting that as well with WAT, or will be very soon once we release the mapping. So this is basically the exact same view that I showed earlier with that little red circle, right? The industrial connectivity software here, the reference implementation is called Edge Translator, but of course, Edge Translator is a reference implementation. What do we know about reference implementations from earlier on? Your mileage may vary, right? Use it at your own risk. Don't call me at 3 o'clock in the morning if your production is stopped because the software doesn't work. I'm not going to pick up the phone. So you can use it, but it's a reference implementation. Ask for this from your industrial connectivity software vendor. This thing here, we port into the WAT connectivity companion spec, which is released and available on the OPC Foundation GitHub. It's the most simple API definition ever. It has 2 methods defined. Drum roll, create asset, and delete asset. Plus, it uses the existing file interface that OPC UA defines to upload the WAT file to the industrial connectivity software. That's it. So if any of your industrial connectivity vendors tells you that this is too hard, they're lying. So ask for this because it helps you create choice and simplicity when it comes to WAT connectivity. I'm obviously asking every single connectivity partner that Microsoft has to implement this. You can bet your backside on that, right? But it's much louder when it comes from you as an end user, because you're paying for the software. I can just beg. You can say, well, if that's not there, I don't think I'm going to buy that. So please ask for this. So what does it look like? Here's an example. This is my favorite Centron PAC 4200. I happen to have one of those at home. That's why I always use it. So in here, you can basically define exactly what this thing does. Down here, you have the Modbus protocol binding. Here you have things like security configuration, where it is on the network, IP address, and so on. And then you just have a bunch of properties. The properties are the tags, right? What is it? Oh, it's a voltage between live and neutral. It's a number. It's read-only, yada, yada, yada. Here you have the Modbus address and the number of Modbus registers you're supposed to read, because this happens to be a float. And now, for the first time, we also specify the OPC UA type from the OPC UA companion spec. In this case, it's the Profinet energy monitoring companion spec that tells you where to map this, to what type to map this to. And there's also a hint up here in the context section, which companion spec to download. So yes, UA Edge Translator already does all that. So UA Edge Translator connects to the cloud library, it downloads the companion specs that it needs, including its references, because companion specs can refer to other companion specs, maps them into the address space of its OPC UA server, then does the mapping. Well, first it tries to connect to the device. If it's not there, it doesn't work, obviously. Tries to connect to the device. Yes, it's there, great. Then does the mapping based on the WAT file, and then maps it to these types that are in the companion spec, including support for complex OPC UA data types. What are complex OPC UA data types? It's structs, unions, derived classes, and so on. So these are all data types that are not built into the OPC UA standard. And unfortunately, companion specs make heavy use of complex data types, so you better support them. And yes, I get asked this all the time, well, the reference stack from the OPC Foundation doesn't support complex types in its server. That's true. So Edge Translator implements this by itself, but we're working on a NuGet package which has complex type support for OPC UA servers. Okay, so I got a few more slides, right? You said I have time.
Yeah, you have.
Okay.
No problem.
So that's asset onboarding and web of things and all the other stuff. So now I want to talk about the digital product passport and why that's important for OPC UA. Well, as it turns out, the European Commission has great ideas when it comes to creating new requirements for manufacturers, including the digital product passport, which basically says any product sold in Europe, or sorry, the EU, must have a digital product passport eventually. They're starting with batteries, because batteries are kind of hard to recycle and there are some dangerous materials in them, and we really want to create a circular economy. This is all about creating circular economies, right? And by 2027, every battery sold in the EU that is either put into a mobile product, like an e-bike or an electric vehicle, or an industrial battery that you have on premises, must have a digital product passport. Now, 2027 is just around the corner, okay? So you don't have a lot of time to build digital product passports. What are they? Well, there are two things. First and foremost, it's a QR code on the product. You scan it with your phone, it brings you to a website that has all the information in it regarding the product, like who made it, when it was made, what is its digital nameplate, what's its product carbon footprint, what kind of hazardous materials are in it, how do you recycle the damn thing, all of those things, right? Now, product carbon footprint should set off alarm bells in the heads of all the end users in the audience, because that's not easy to calculate. That will only work if the data along the supply chain that you need to calculate the product carbon footprint is standardized. If everybody sends data somehow to you, you're not going to be able to scale to that. It's that simple. So we need standardized data exchange along manufacturing supply chains. And that's exactly where OPC UA comes in. Because the cloud initiative is all around interoperability of cloud applications. So not just OPC UA is used, but also these other two technologies, the Asset Administration Shell, which is a standard, it's an IEC standard developed by the platform Industry 4.0. now run by the Industrial Digital Twin Association, these guys. And the Eclipse Data Space Connector, which is another component that handles digital contract negotiation. So basically contracts negotiated between a supplier and their customer when it comes to accessing things like the digital product passport. So the output of the EDC is basically a security token that you can then use to access the data for the digital product passport. And for the longest time, the IDTA had some ideas on how the digital product passport should look like. The OPC Foundation had some ideas how the product passport should look like, and it didn't really fit together. So together with Siemens, I decided to come up with a proposal where both technologies can be used to complement each other rather than fighting each other. And we announced this 2 weeks ago in Oak Ridge in the US, because in the US, we have the Clean Energy and Smart Manufacturing Innovation Institute, which is like the platform industry for in the US. They're Department of Energy sponsored. And they've already hedged their wagon on OPC UA technology. So they call OPC UA companion specs smart manufacturing profiles. I don't know why they had to rename them, but they did. And they, of course, had a vested interest for the digital product passport to also use OPC UA technology because they've already built a lot of infrastructure for OPC UA. So initially, it was just those three organizations that made the announcement. And then it kind of snowballed out of control, and then everybody said, oh, we want to be part of it as well. So then we had the Labs Network join in, and the International Manufacturing X Council, the ZVI, E-Class, Digital Twin Consortium, VDMA, and the Industrial Data Space Association with this symbol here is the EDC symbol, the Eclipse Data Space Connector. And they all agreed, this is it. And then we made the same announcement last week at Smart Production Solutions. So hopefully, this is it when it comes to digital product passport technology. And the digital battery passport is just a specific digital product passport for batteries. It also has some real-time information, or not real-time, live data from the battery, how many charging cycles did it have so far, and all those kind of things. So there is some usage data also part of digital product passport, because quite honestly, if you buy an electric vehicle, what's the most important thing you're interested in? Well, what's the condition of the battery? Because if the battery is dead, your car is useless. The battery is the most expensive part in an electric vehicle, so you want to make sure that the battery is in good condition. So the digital product passport helps you with figuring that out. So with Sesame, we created this demonstrator. So they have their own modeling tool that they call Smart Manufacturing Profile Designer. Again, everything that's a smart manufacturing profile is nothing but an OPC UA information model. So they create this thing, and then they embed the profile or the OPC UA information model, which is a nodeset file. A nodeset file is the file format for an OPC UA information model. Integrate that into an asset admin shell, and then store it in an asset admin shell repository. We contributed one to the Digital Twin Consortium. It already has that capability, so the one that is in the Digital Twin Consortium's GitHub is capable of loading basically OPC UA nodeset files. But since we have a digital product passport built on OPC UA technology, of course, we can also store it in the cloud library. How great is that? So we have, for the first time, the infrastructure to build these digital product passports at scale. And how does that look like in detail? I'll explain now. So why combine the OPC UA technology with the asset admin shell technology? Well, as it turns out, OPC UA has been part of the asset admin shell spec all along. And nobody bothered to actually implement it, so we did. It was actually pretty straightforward because you just load a nodeset file. Big deal. So there's also a joint working group that basically takes the semantics from the asset admin shell and applies them to OPC UA. Just like a robotics companion spec that takes robotics semantics and applies them to OPC UA, this working group takes the asset admin shell semantics, and they have things like asset admin shells and submodels and submodel elements and submodel element collections and those kind of things, right? So it's just different terms to basically create a structure of your asset admin shell and, define the data in it. And they have then a bunch of submodel templates for different things like digital nameplate, product carbon footprint, you name it. There's almost 100 templates now available from the IDTA website. So all of those can be mapped to OPC UA using this companion spec. Now, those of you who are familiar with the subjects will say, version 1, it's out of date. You are right if you said that. So we're working really hard to get this companion spec to version 3, which is the current version of the asset admin shell. Get that updated. So there's a working group currently running that does exactly that. So this works for version 1. For version 3, you got to be a little patient. Is there much difference between version 1 and 3? No, there isn't, so it's not a big deal. All the modeling that I've done so far is with version 1. It works fine. So there's a REST interface for OPC UA, right? I already talked about that. It's going to be released in the next version of the OPC UA spec. And the biggest benefit probably is the fact that OPC UA has been around for so long, and there's so many good commercial and sometimes free of charge OPC UA modeling tools available for OPC UA, and there just isn't for the asset admin shell. There's one modeling tool that is open source, and you basically have to compile it yourself. It's not great. Customers just want to buy a product and use it. So this is probably the most important benefit of OPC UA. It's rich data modeling capabilities and the fact that you can just get tools for it. It's just simple. So that's why OPC UA plays a role in here. And then I already mentioned the submodel templates from the asset admin shell specification available from the IDTA website. And they can be, right now I manually converted a bunch of them to Node-Z 2 together with the OPC Foundation, of course. We had several demos where we did the conversion. But potentially this can be done automatically, and I already have an idea on how to do that automatically, so we'll do that next. And then, of course, it also has a REST interface that we can now support because we can support the semantics that it comes with. So its REST interface has things like get submodel element, get asset admin shell. So to make that work, obviously, you have to model a submodel and an asset admin shell and a submodel element. If those things don't exist in your OPC UA model, those method calls are not going to return anything on the REST interface. So we will also support the asset admin shell REST interface, but also the OPC Foundation REST interface. And then finally, the asset admin shell also defines a file format, which is nothing but Office OpenXML. If you don't know what that is, look at your Word or PowerPoint files. They're PPTX or docx, which kind of gives it away. It's just Office OpenXML, which is nothing but a renamed zip. It's a zip file that was renamed, and you can just rename your Word docx file to zip and then browse into it and see what's in there. It's basically has a content XML file in there describing the content, and one of those content files is now going to be the Node-Z XML from OPC UA. So it can contain Node-Z XML, and that's pretty much it. So I already mentioned the EDC. It covers the data sharing service, let's say. So basically, who can access what data when. And notably, it doesn't cover the actual data exchange. That's covered through the asset admin shell and OPC UA technology. But the EDC plays an important role when it comes to supply chain data sharing, and it covers basically the authentication and the authorization. That's it. Remember this? Well, this is what it looks like for the digital product passport. So like I mentioned, the interface will be a combination of the Open API from the Asset Admin Shell and the OPC UA REST interface, and then which covers the data exchange, and then the Eclipse Dataspace connector for the digital contract negotiation. The data format, like I mentioned, are those two things: an Asset Admin Shell exchange file and a node.set XML within it. The data model, yes, you guessed it, it's OPC UA, which means that you can use all of those great OPC UA modeling tools like Siemens Sioma or the SESMI Smart Manufacturing Profile Designer, which I mentioned. The Smart Manufacturing Profile Designer is available online. You just register and you can use it. And it integrates with the cloud library, so it's all there, but you can also load your own models to it. And then, like I mentioned, the semantics are the Asset Admin Shell semantics. We put eClass in there because some people want to have those IRDIs in there to describe basically it's like a tag dictionary. And then finally, we're going to convert the Asset Admin Shell submodel templates to node.set files so you can use them as well. So that's how it all fits together. So here's the conversion tool. So we will go in and basically download the submodel templates from the IDTA GitHub. We're going to import them into a converter tool, which has an OPC UA server in it. In there, we load the I4AES companion spec so we can do the semantic mapping. That'll create a node.set file, which we can then store in the cloud library. That's it. So this is what the Asset Admin Shell repository looks like. So it is much simpler than it used to be, trust me on that. So now we basically just load these ASS package files, which again are just renamed zips, or we can load node.set files directly into an OPC UA server. And for the REST interface and this visual tree builder service is nothing but a UI, so you can actually look at it, right? And to basically connect the REST interface and the UI to the server, we just stick in an OPC UA client that does the reading. Simple, yet effective. There are some other things that we integrated in the meantime. So there's a PubSub service for example, for the live data for the battery, right? So if the battery is in an electric vehicle, you need some way to basically send that data into the Asset Admin Shell or into the digital battery passport. That's done through the PubSub service. It's basically a PubSub client, right? Of course, I couldn't resist but integrate Azure Data Explorer. Don't blame me for it. SESMI have their own smart manufacturing innovation platform, which uses a GraphQL interface. I integrated that as well. And then I have a calculation service that basically calculates the product carbon footprint. Maybe on that, the energy production or the carbon footprint that you emit during the production is less than 10% of your overall product carbon footprint. 90% comes from your supply chain. That's why this is so important. You must also consider the carbon that is emitted further upstream before you end up assembling your final finished good, your final product. Otherwise, it's greenwashing. It's as simple as that. And there's a lot of that going on, unfortunately. This is a solution to stop greenwashing because for the first time, we have the technology to actually build the product carbon footprint properly. Now, I know it's hard and I know it'll take time and you need to convince all your suppliers to use this, but I don't really see an alternative. I don't. So get on it, right? And that's it from me. Thank you very much.
Thank you very much, Erich.